This lesson comes from Go Math Lesson 3.3, in which we're using rational numbers and the number line. And if you notice, the essential question reads, how can you plot rational numbers on a number line? Well, that lets you know we're going to be working with number lines today, and we're going to be plotting rational numbers on. Well, let's take a look at what it says a rational number is. It says a rational number is any number that can be written as a over b, where a and b are integers and b is not equal to 0. Fractions, decimals, integers are all rational numbers. So let's make our little rational number umbrella. And let's just make sure we know that under this umbrella includes decimals, fractions, and what we just discovered, integers. So rational numbers are not just positive and negative whole numbers. They're decimals, they're fractions. They may be positive decimals, positive fractions, negative decimals, negative fractions are all included in rational numbers. And the other problem reads that the freezing point of a liquid is the temperature at which the liquid turns into a solid when it's cooled. The table shows the approximate freezing points of various liquids. We are asked to graph each temperature on the number line. Where are we getting the temperatures from? This table right there tells us carbonated water's freezing point is -3/10, fizzy lemonade -5/10, and hydrazine is 1 4/10. Well, step 1, they want us to locate each number in relation to the nearest integers. Okay, that seems like we're kind of estimating, which is absolutely fine to do. Well, -3/10 is the opposite of what? +3/10. And so +3/10 is between the integers of 0 and 1. So that means -3/10 is going to be between 0 and -1. What about -5/10? Well, the 0 tells me that definitely is between 0 and something, and that something is also -1. But what about this 1 4/10? Well, I see a 1 here, so it's fair to say that it's above 0 and far enough above 0 that it's between 1 and, well, that's 4/10, 2. So we've now got our estimates, and what I want us to also do is now on this number line is actually highlight our benchmarks, our numbers that they're going to fall in between. And so if you notice this number line, it is a vertical number line. It goes up and down. And we've got 2, some numbers, something, tick marks 1, 1, 0, -1, 2. We're not going to worry about that just yet. What I want you to do is highlight the benchmarks that these numbers are in between. So we've got 0 and -1 is the 3/10. 0 and -1 is the 5/10. And then 1 and 2 is the 4/10. So we've got our benchmarks. Now it's time to actually get to the nitty-gritty and get to plotting these. Well, when I looked at this number line, the first thing I noticed was that there were marks in between. And those marks in between are not labeled. And so what does that mean? That means we're going to have to determine what those values are. And I feel like the fairest way and the safest way to do this is to first count and see how many marks are in between. 1, 2, 3, 4, and then 5 between I get to the next number. Could it be that this is 1/10, 2/10, 3/10, 4/10? No, 5/10 is not the same as 1 whole. So it's not by ones. Let me count by twos. 2/10, 4/10, 6/10, 8/10, 10/10. Is 10/10 equal to 1? I got it. The tick marks in between are 2/10. So this would be 2/10, this would be 4/10, this would be 6/10, this would be 8/10. On the flip side, that means that this is -2/10. This is -4/10. This is -6/10. This is -8/10. And as you mark each of these, you're going to realize it's purposeful. Because remember what we were plotting. We're plotting -3/10. Well, where would -3/10 be? It's going to be between the -2/10 and the -4/10, right smack dab in the middle. Put an arrow and let's label that this is -3/10. Now, I know your book is a little smaller. You can't do the zooming in like I'm able to zoom in, but I do want you to mark these tick marks in between so that we are certain we're being precise. All right, what about the next one? Well, we're still working in between 0 and -1, so I might as well go ahead and label those once more. This is the -2/10. This is the -4/10. This is the -6/10. This is the -8/10. And we're looking at -5/10. So what would that be between? Let me just put parentheses so you can see. It's going to be between the -4/10 and the -6/10 comes -5/10. Write this. Okay. And then the next value is 1 4/10. And we know that this is 1. This happens to be 1 2/10. This is 1 4/10. Let's just still label it just for the sake of, and we know we're plotting 1 4/10. So what was the first thing that we did? The first thing that we did was we identified what would be the integers that that number value falls in between. Here for the -3/10, we said between 0 and -1. Well, that would make sense, right? Because there's a 0 here and it's not quite the whole number 1 or -1. And the same thing for the -5/10. It would make sense. Yep, there's a 0 here. It's not quite near a negative whole number, so it's going to be between 0 and -1. And the 1 4/10 is between 1 and 2. All right, let's move on to the next page. The next page, we've got a map. City Hall located in a particular map. That's the stipulation it has. And it says that we've got the map of Maple Avenue. Other points of interest are indicated by their distances in miles to the right of City Hall. And just show you, to the right is the positive, and to the left are the negative numbers. And we're asked to graph each of those on the number line. And so we've got the values right here in the table that give us the location of them, and the location of City Park, -3/8, Fountain, -1 1/2, the library is 1 1/4, and the mall is 3/4. Well, we're again asked to do the same thing as find our benchmarks. So -3/8, where is that between? Wasn't -3/8 close to -4/8? And wouldn't -4/8 be like 5/10? Almost a half. So we're definitely going to look at it being between 0 and -1. Well, what about -1 1/2? It's bigger than -1, so it's not quite -1, but it's not as small as 0. So it's going to be between -1 and -2. The 1 1/4, it's a positive mixed number. It's going to be between 1 and 2. Then 3/4 is going to be between 0 and 1. This is all number sense things that should come to you. Now, the graphing each of these on the number line is going to look a little different because we have now a horizontal number line. And in this horizontal number line, it looks like we've got a lot more tick marks or a lot more values. Well, let's count. Let's see. 1, 2, 3, 4, 5, 6, 7, 8 lines in between. Could I think of them as actual eights? That this would be 1/8, 2/8, 3/8, 4/8. Is 4/8 a half? Yeah, it is. 5/8, 6/8, 7/8, 8/8. Yeah, these are in eighths. So this is going to be a lot more reasonable to plot because now we're working with values that we could find equivalent fractions of. So this -3/8 is going to be, again, like we said, between 0 and 1. So let's highlight that, 0, -1 rather. It's going to be somewhere here. The -1 and 1/2 we said is going to be between -1 and 2. So it's going to be somewhere between here. And then the 1 and 1/4 is going to be somewhere in between 1 and 2. So let's go ahead and plot it. Well, I know this is 1/8, 2/8, 3/8. And in this case, it's -3/8, we know. We're not going to put the marks for in between here, the number values, just because it's so small. But again, if you want to and you feel comfortable, do it, sure. Well, if this is 1/8, 2/8, 3/8, 4/8, -1 and 1/2 is equal to -1 and 4/8, right? So we're looking at it as being right there. And let's go ahead and mark it, -1 and 1/2. And doesn't that look like it's right smack dab in the middle of -1 and -2? And then lastly, 1 and 4/8, well, we're here, 1 and 1/4. Well, what is 1/4 equal to in terms of eighths? 2/8. It is. So we've got 1 and 1/8, 1 and 2/8, 1 and 3/8, 1 and 4/8 if we were going to do that. But here we go 1 and 1/4 because it's equal to the 2/8. Now, in this particular example, there were a lot of skills we brought in. We had to go back to looking at making equivalent fractions. We looked at the eighths value. We also did use the concept of the benchmarks like we did in the first example. And so please keep that in mind as you work today. I'm going to have you all do the questions 1 and 2 on your own. How did you identify the two integers that are between -1 and 1/2? And then how do you know from looking at the table that City Hall is between the library and the mall? And make sure you answer these 2 questions before moving on to your share and show. And after the share and show is done, you're going to go ahead and get an organizer for the on your own. Oops, I forgot one more. 3/4. What's 3/4 in eighths? 3/4 in eighths is 6/8. So I've got a plot. We almost forgot about that one. How did we get away with that? And we remember that 3/4 was going to be between, if you remember, what 2 numbers? 0 and 1. So 0 and 1. And we know it's equal to what 6/8 would be. So we know that this is 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, and 6/8, which is 3/4. And some of the questions today, you are going to have to convert them into an equivalent fraction to allow the plotting of it to be more manageable. All right, best of luck.